The one that's got like the 25 different parts to it. So region S is bounded by the graph y equals x equals 0, and y equals 3. First, we're going to sketch. Y equals x equals 0, y equals 3. So what y'all's look like? Let S be the base of a solid with cross sections perpendicular to the x-axis. Oh, this is good review for us. I didn't realize this was on here. What? Oh, okay. Well, what's the area of region S? How do I do that? Did you integrate? Did you use calculus to do it, or did you use geometry to do it? Nobody used geometry? It is a triangle. I probably would have used geometry here, but you don't have to. You can use area under the curve would be the integral from what to what? Are y'all okay? Top minus bottom. So 3 minus x. So what y'all did? 3x minus a half x squared from 0 to 3. 3 times 3 minus a half times 3 squared. 9 minus 9 over 2, which would leave me 4.5, right? So it leaves me 9 over 2. Are y'all just done? Thank you so much. That is not all right. That's all right. All right. They're warm too. Warm since you want me to bring you one? You want one or two? So that we've ever gotten them warm, probably because I always pick them up from the upstairs. Oh, that's okay. That's all right. Lauren, is that what you got whenever you did 1/2 base and type? Yeah. Much easier. It is. I agree. But what it doesn't matter. You can use calculus, geometry, whatever you like. All right. Yes or no? All right. That's the region. That's part A. Part B. Let S be the base of a solid with cross sections perpendicular to the x-axis. So here's my cross section. Form a square. So I'm going to do, this is find the volume of the solid. I'm going to do the same kind of thing, but I'm going to find the area of one square, and then I'm going to integrate the area. So okay with that? All right. So the area of the square, let's first find the side length. That is my cross section. What is that? 3 minus x. So then the area of the square, you just square it. So then the volume of the cross section, I'm still going from 0 to 3, and I'm doing 3 minus x squared. Yes. And it says use a calculator after you set up the integral. Bless you. You're welcome. Did I post the answers for these? If I go math 9, I want y1 squared x from 0 to 3. I got 9. Everybody get 9? Part C, let S be the base of a solid with cross sections perpendicular to the y-axis that form a semicircle. So this time, here is my cross section. And it forms a semicircle. So I'm with respect to y instead of with respect to x, but my equation is just y equals x, so that makes life a little bit easier. So if I'm a semicircle, then what is the radius of my semicircle? So this is, remember, this is my diameter, right? Because my semicircle is sitting right there. So it's going to be a half of, this is where it's a little bit different than the other, right? So that circle is just sitting right there on, coming out at you, right? So that's the whole diameter, so I need to cut it in half to find the radius. And so I got a half times, and then what is this distance here? It's just y, right? Because I'm in terms of y this time. So the area of my semicircle, and here again it gets a little bit confusing. If I write this as y over 2, it might make a little bit more sense. So the area, because it's a half of a circle, it's going to be half of, and now I need to do the radius squared. Oops, pi r squared. Half of pi r squared. And so the area here, pi over 4 y squared. That's just the area. Now I need to integrate for the volume. I'm going from 0 to 3. This time I'm going from bottom to top, but because y equals x, that point is still 3. And I'm going to actually put the pi over 4 on the outside. That makes life a little bit easier because this is a much easier integration problem. It says, though, to use your calculator. It would. Already today. Already. Because that's squared. So if I just make 3. I got 9 pi over 8. So what y'all got? And now the good stuff. Write the equation for the big radius and the little radius. That's the hole in the hole. For the solid of revolution when revolving S around the given line, then set up the integral to find the volume of the solid. Don't subtract the radii, instead subtract the areas. All right, so let's set it up. This time I'm revolving around the line x equals 3. Okay, so x equals 3 is revolving around this line. So now little and big. Y'all agree? What's the length of big R? Or what? The whole radius. This is it's just 3 all the way over. The whole thing. But that's, I want everything included. I want the whole, the HOLE whole, included in that big one. Now for the little one, what I'm taking away from it, now this is the white area. Okay? So that I'm Right. So I labeled my radius. I labeled my, oh my gosh, get your crap together. The radius of the whole thing minus, that's going to give me the whole. This, not this, this is my whole part. That's what I need to take away, right? Does that make sense? Not this. This is what I need to take away. If I take the whole thing and then I subtract out what I don't want. Okay, so the whole is your 3 minus y this time, because I'm going around this way. Right? So then it says the volume, so I need the area of each one. The area of the entire thing is going to be 9 pi. Right? Pi r squared. And the area of the whole is going to be pi 3 minus y squared. So the volume is going to go, and I'm going to use my y's from 0 to 3. They both have a pi. I'm just going to put this outside, and I'm going to do the whole minus whole. Makes sense? So again. No, if you wrote this one, you could write as 3 squared. But because I've already done the area of each one, I just square each one individually. Because remember, that's where I got mixed up yesterday. If you've got this whole circle and then you take a piece of it out, the shape you have left is not a circle. It's some kind of funky shape now. So I can't just subtract the radius of each one. I have to actually do the area and the area and then subtract that. So I wouldn't want to square it again. And I don't know what that comes out to be. Okay. Y'all okay? All right, E says the line y equals -1. I'm going to draw this. Here's my shape. This is 3, 3. This is y equals 3. This is x equals 0. This is y. And I'm rotating around the line y equals -1. So everything's flipped. So here's my whole radius. And what I need to take out is the whole. Does that make sense? All right, so the radius, the whole radius is going to be, what's the length there? This is why the picture is so important. Yes, so from 3 to 0 is 3, and then another one is 4. And the whole, well, this distance is just x, right? This time I'm going with respect to x. But to it, and if you do top minus bottom, it's x minus -1. Or if you just look at it, you know, you add 1 to the length there. So, well, this time I just want the white space. So from here down to the line I'm revolving around. So this distance is x. Do you agree with that? Is what the same thing? 4 minus x is going to give you this space. So this one, because see, I subtracted, I'm going a different way with this one. So this one, this distance was 3, right? This distance is all the way across, so 3 minus from here to here, which is the y. So same thing, but I flipped around. I'm going the other way. Does that make sense? Y'all are looking like it doesn't make sense. Okay, where are you getting 4 from? Oh, you're saying you're taking this whole thing and subtracting that. I see what you're saying. You should get the same thing. It should come out once you plug it in and evaluate it. That should come out to be the same thing because you are doing. I have to visualize it and I have to see it and I have to measure the whole from where I am. Both of those are definitely the difference. Does that make sense? If this whole thing is 4, is what they're saying, then if you subtract out, they're doing whole minus shaded to find the whole. What I did was I just looked at it and measured the whole. The whole is here. Right. It should come out to be the same whenever you do it. We'll do it both ways and see, but it should. So whole, like W whole, not minus the whole, but minus the solid, minus the shaded. That's what y'all did here, and that would work. Like you could do the whole thing, which is 4. So we did the whole thing, which was 3. And then we subtracted out the shaded part so that we were left with the white part. No, it's W minus okay. When we do the area, yes, but remember you can't subtract the radii that way because you're not working with circles. Well, that's what we did over here. Yes. Okay, but go back, just move it right here. So on this one where you did x minus -1, why are you doing that? Well, that's what we do. I'm thinking you should get the same thing either way you do it. Let me from here to the x-axis, which is what you'd get with the equation itself. The area of the shaded is going to be the whole thing minus all of this. Right. This distance is x. This distance is 1. This distance is 3 minus x. Right? So now if you look at it like this, if you want the entire thing, well, that's this plus this plus this. We haven't gotten to that point yet. We're going to use it. I was trying to help you understand why this is x plus 1. Because that's the radius of the white hole. You want me to draw another picture that's clean? Now I have to find the area of each one. So pi r squared, 16 pi times x plus 1. So now I do everything, and this is where I'm doing my volume, right? I'm going to pull that pi out. I'm going to go, this is in terms of x, so I'm still going from 0 to, what was it, 3? 0 to 3, and I'm doing area of the entire thing, which is 16, minus the area of the white space hole, which is x plus 1. Let's do around -1. Same shape. I almost wish this was y equals something else so you could see. I feel like the y ones over the y equals lines, those are the most common. They're a little easier to see. All right, x equals -1. This time I'm back to respect to x. To y. Right, because this time I'm rotating around. All right, I've got the whole radius, and I've got the whole radius. The whole thing, remember this is y equals x, and I'm going with respect to y because I'm twirling around like a carousel. Y plus what's the radius of the part that I'm subtracting out? 1. So now I need to do the area of each one. So the whole entire area is pi r squared. The area of the white space well, this one's flipping because I'm going this way with it. What do you mean, why? It's always the whole thing minus the shaded area for your H hole. Is it because we're flipping between rotating this way and this way? Okay, I think because my line on this one was below the axis, maybe that's why it was. Let's do another one. Let's don't get hung up on that one. Let's do another one. Let's do one let me finish this one. Volume here is going to go from what to what? I'm still 0 to 3. I'm going to put the pi out here, and I'm doing the entire thing, which is y plus 1 squared minus the white space hole, which is just 1. It says region R is bounded by y equals, okay, I'll just write the problem here. All right, I'm going to go ahead and start sketching this region. This is the bottom right of the first page, the one that says 192 pi. All right, y equals x squared. That is just a parent quadratic. X-axis and x equals 2. This is x equals 2. This is y equals x squared. This is x equals 0. And it says also bounded by the x-axis. So my little shape that I'm working with is right here. I always go ahead and find points of intersection. I find it easier than having to go back and do it. So this is obviously 0, 0. This point is on the line x equals 2. If I plug that in, I get 4. And I'm rotating about the line y equals 4. So do I have a hole? Do I need to use a washer or a disc? Because the difference here is if I've got to use a washer, that's where I've got to subtract my areas. If it's a disc, it's not quite as complicated. A washer, right? All right. So that means I need a big radius and a little radius, a whole radius and a whole radius. If I'm rotating around that green line, what is my entire radius? 4. All the way up, right? All the way up. What is the hole in my washer? What's the middle of my donut? That's right. I think this is why you were confused on the other one. The other one shaded up instead of down. So to find the distance, here it's a little bit easier to find this hole because the shaded area is the curve itself. If my shaded area, if this were my shaded area on the other side though, let's just say it's on the other side, then to find this white space hole, okay, we're not going around the y-axis, we're going around the line y equals 4. And y equals is a horizontal line. So I'm rotating around a horizontal line. So that's, no, it's just normal. When it's revolved this way. When it's, yeah. Well, and not even if it's on the other side, but if if the shading was reversed, it would be a little harder to find. It's a little different to find that hole, right? Because then I would be doing this distance. I wouldn't have to do 4 minus all of this. I could just go from here to here to find the hole, if that makes sense. They're all different with the pictures is what I'm getting at. Depending on where your shading is and all white, that's why it's real important to draw your picture, to look and really look at what it is you're finding to help you. Instead of me just saying always do this minus this or always go this way, because depending on the rotation and depending on where that white hole is going to be dependent on how I find it. All right, so now, so area of the whole big thing is 16 pi. Area of the white hole is going to be pi times 4 minus x squared. That's the curve. This distance is x squared. So now the volume is going to go, I'm going to have a pi on the outside. This is to use a calculator, so are any of them, but they're all fractions. I'm going to go from 0 to, I'm going with x, so am I going from 2 or 4? 2. And I'm going to do the whole thing minus whole. So I would put this on the calculator since this one has 2 asterisks by it, and I'd do math enter. See if it'll work. Let's see. Hold on. How'd y'all get that in there so fast? 16 minus 4 minus x squared. I got 224 pi over 15. Which is actually the very next answer up top on pi. Which one? After I calculated it on the calculator, I hit math enter. Don't put the pi in. Leave the pi out. The pi comes from the outside here. All of these, you're just going to throw the pi on in the end. Y equals 4. Robert, we're doing the first one. If you watch this. X equals 6, x-axis and y-axis. So I'm a square here, or a rectangle, right? It says that it's rotated about the x-axis. So my radius is here, right? There's no hole, so I don't need to use a washer. I can just use a disc. Here's my radius. What is that length for? So the area is 16 pi. And if it said it's rotated about the x-axis. So down the volume, I'm going to pull the pi out, and it's going to be the integral from what to what? Am I respect to x or respect to y? Respect to x, so then that tells me I go from what to what? 0 to 6 of 16 dx. What does that give you? 96 pi?